Hello YouTubers, Dave out in Western Pennsylvania, USA. Here we're conducting what I define as a dry circuit. Please refer to my other videos. A section of graphite, commercial graphite felt. This felt has a resistance measured with a multimeter of about 9 ohms per centimeter. And fairly conductive for my supercapacitor studies. So here in the dry circuit, I have the graphite, the dimensions, always important, 5.5 millimeters width, 40.4 millimeters length, 2.9 millimeter thickness. And that would be plus or minus 0.1 millimeter for each dimension, measured with a caliper. I have it enclosed in a plastic sleeve, sealed, except for where the leads come out. And I'm using a breadboard for convenience because I'm not moving it around. You can see I have it inserted into the circuit, the leads. Incidentally, 18 gauge copper leads are used. So I'm running the dry circuit. There is no electrolyte, no DES, deep eutectic solvent or ionic liquid. It's as is. I did not clean it. But it has been sprayed 3 times. 3 times each side, with 20 minutes in between each spray, each coat, aerosol graphite felt deposited on both sides. So I have aerosol graphite deposited on the graphite felt. Want to see how this performs. And of course, this could increase the surface area. It's part of our studies. And we also use the scanning electron microscope to examine the graphite materials. Here it's felt. I also use yarn, graphite yarn. So I'm at 3.9 constant voltage. I started up the circuit, which also has an LED electronic load rated for 5 watts. And I have the graphite hooked up to the negative lead. Sealed in the plastic, as I said. The mass of it, 2.580 grams, and that includes 12% mass deposition of aerosol graphite. The current started at 0.09 amps, and it ranged from 0.09 to 0.10 amps, so 90 to 100 milliamps. It's been pretty steady now, and I started this run up at 3 o'clock earlier today. It is now my time, Eastern time, 5 minutes short of 6:30 p.m. So it's been running for 3.5 hours. I'm going to let it go for a day or two. I want to see if there's any change in the current, which would indicate changes in resistance. Now remember, graphite is almost like a semiconductor in the sense that when temperature increases, unlike copper, it will become more of an insulator. And I've not hooked up a thermocouple yet, but I have never felt anything warm to the touch, either the breadboard or any sample I'm running. And I want to see if there will be any changes in resistance. And then I will follow up with a wet run where the graphite, the same material, will have coating of a deep eutectic solvent, and the ones I use dissolve lithium bromide. At least 18% mass. And then I will also do cycles of charge discharge with an electronic load and a 3.7 volt lithium ion secondary cell, so I can do cycles of charge discharge. I'm running one right now, a somewhat related study. I'm running one right now, which I can show you for those that have not seen my videos. Switch over. There's my one of my plants here, passion lily. And won't be going outside here in northern Pennsylvania, northwestern Pennsylvania, till about May. But I'm also running, this will now be completion of 300 cycles of charge discharge with a related graphitic material. This is a wet run. I'll be posting this in a separate video. There's the 3.7 ion lithium secondary cell. And this will be a measurement of coulombic ratios, efficiencies for capacitances with charge discharge. So we'll upload that soon. I use a ZKE Tech electronic load device, and that would be an EBC-A10H. For cycles, get the 10H, not the 20H model. Thanks for watching. We'll keep you posted. Bye for now.